Hello, you splendiferous students. Let's get into today's lesson, which is more of 8.8c, the readiness standard. We're going to use inverse operations to isolate the variable. So go ahead and flip to page 6, because that is where we will get started. I know the title is modeling and solving. I just feel like models are so stinking easy. So equations can be represented using shapes, symbols, and operations. So, for example, number 1, I see 4 x's and 2 1's, which I can clearly deduce that that is 4x plus 2. Then I see a negative x and 7 1's, so negative x plus 7. And I know they're equal to each other because there is an equal sign. So from here, I'm going to go back to what we did previously and draw my line, circle my terms with a variable in it so I know which one I'm moving first. Now, negative x is smaller than 4x, so I'm going to move that guy first by using addition, which is opposite of negative. So those cancel out. 4x plus 1x equals 5x. Bring down that 2 because we haven't done anything with it yet. Bring down the 7. Now I am going to move this positive 2 over, and since I'm moving them over, I need to do the opposite of addition, which is subtraction. So 2 minus 2 equals 0. So I bring down that 5x equals 7 minus 2 is 5. Last operation is divide by 5 to both sides to really isolate that variable. X should equal 1 because 5 divided by 5 is 1. Now, if this does actually work out and each x equals 1, if I have 1 here, and then those are 1s, and then this is a negative 1, right? Because negative x, negative 1, does 1, 2, 3, 4, 5, 6, 6 equal 1, 2, 3, 4, 5, 6, 7, negative 1 plus 7. And why, yes, it does. So I know x does equal 1. Cool. Beautiful. Love that. Now let's do number 2. We still have some symbols. We have a different variable, but nothing too freaky. This is what we call a scale, like this thing that they're on. Like this whole contraption, that's a scale. So sometimes you'll see one side bigger than the other. Well, that means one side is less than or greater than the other. But in this case, they're equal to. So I see 3 y's, so I'm going to pull out 3y. I see 4 1's, so plus 4 should be equal to, because again, the scales are balanced, negative y minus, because how many negative 1's are there? 6. So minus 6. Boom shakalaka. Draw my line, circle my terms with the variable in it. I'm going to move this negative y over to be 4y, bring down that 4, bring down the negative 6. Inverse operation of moving that 4 over, it's going to be subtraction because it's the opposite of addition. 4y should equal negative 10. Lastly, divide by 4. Therefore, y should equal negative 5 over 2 or negative 2.5. I think either answer is appropriate. I would honestly leave it as a fraction. Cool. So basically, we're doing the exact same thing we've already done, but we've got to write it first, judging by the symbols. So I'm just going to have you guys do the last 3 on your own. See if you can do this. We will go through it one at a time. And if you're making mistakes, then heck, just analyze my work, see where your work looks different than my work, and then maybe that's your mistake. Let's get into it. Number 3. All right, so x equals negative 3 over 5 or negative 0.6. Either one, I don't think it matters because you all know how to change fractions to decimals and decimals to fractions. Cool. Let's move on to number 4. All right, beautiful. It looks like x equals 5/3 or 1.6 repeated. So x should equal 7/4 or x should equal 1.75. Awesome. There we have it. I feel like it was really quick and simple, mostly because you guys already know how to do most of it. It's just, writing it from the model and then doing inverse operations. Easy peasy.